Hey everyone, today we're looking at the law of cosines. This is section 6.3. The law of cosines covers side, 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 and side, angle, side. We're also going to look at applications of oblique triangles and Heron's formula for the area of oblique triangles. And then finally, we're going to finish up with the proof of the law of cosines. So let's really quickly review what these letters mean. We have side, side, side means we're given the three sides. Side, angle, side means we're given two sides and an angle in between them. Side, side, angle, two sides, but the angle's not between. Angle, side, angle, two angles with an included side. And angle, angle, side, two angles with a side not in between. For the law of cosines, we are going to cover the case for three sides and for two sides with an included angle. So the first thing we have to do is write down what the law of cosines is, use it some, and then we're going to prove it. If we have a triangle with sides A, B, C, and angles opposite, capital A, capital B, and capital C, then the law of cosines states that side C squared is equal to side A squared plus B squared minus 2AB times the cosine of C. You always start and finish with the same letter. B squared, see that we've got a cosine of B, so those match, and then all the other letters are the other sides. So B squared is A squared plus C squared minus 2AC, cosine B, and then little a squared, you see that the cosine is the same, and we've got all the remaining sides, B squared, C squared, BC. So A squared is B squared plus C squared minus 2BC cosine A. And what is really neat is, what is the cosine of 90 degrees? Absolutely. If one of the sides, if one of the angles was 90, the cosine of 90 is 0. And let's see what's left. A squared equals B squared plus C squared. So if the angle is a right angle, then the side opposite must be the longest side, must be the hypotenuse, and the other two are the legs. So we get the Pythagorean theorem, which is really cool. So this law of sines actually includes the Pythagorean theorem. And again, anytime you're given three sides or two sides with an included angle, you're going to use the law of cosines. Really quickly, why don't we have the included? Here I've been given an angle, and another angle. What if we're given three angles? Can we find all of the information uniquely about that triangle? Can we? Exactly right. We could have the triangle with, let's just say we have, for example, 30, 60, 90. I can't draw, but okay, here we go. Here's another 30, 60, 90 triangle. The first one, I'm going to let the side opposite the 90-degree angle be 1. Then the other sides, let's see. The side opposite 30 will be 1/2. The side opposite 60 will be square root of 3/2. What if the side opposite 90 degrees were 2. That would mean that the side opposite 30 degrees would be 1, and the side opposite 60 degrees would be square root of 3. 2 different triangles with the same angles. And that's why if we're given 3 angles, we cannot solve the triangle because it's not unique. So let's say that we're given side A is 11, side B is 5, and the measure of angle C is 20 degrees. It doesn't matter how you draw it, as long as the angles are opposite the matching letter. I'm going to call the lower angle C. That means the side opposite it must be little c. I want to call the angle to the right A. That means the side opposite must be little a. That means the remaining angle must be B. So the side opposite is little b. So I just drew them any old way. And let's see what they've given us. A, B, and the measure of angle C. I use different strokes because these are all different measures. Well, no matter how we draw it, BCA is going to include angle C. So we do have side, angle, side. Great. The first side we want to find is the third side. We're given sides A and B, so we want to find side C. We know that C squared is equal to, I put the other letters, remember, B squared, A squared, and then minus 2 times, it'll be AB, and the cosine always matches, so it'll be the cosine of angle C. But I want to find side C. I'm going to take the square root of both sides. So side C is the square root of A squared plus B squared. These are added, so we can write them in any order, minus 2AB times the cosine of angle C. When I'm putting this in a calculator, I'm going to put the cosine C first, then multiply it by A and B, then multiply it by a negative 2, and then add that to A squared, and then add that to B squared. Then take the square root of both sides, and that'll be C. Remember that C is a length, so it's only going to be positive. We don't have 2 values for the square root, even though we're taking the square root of both sides of the equation. All right. Sorry about that. I got a really nice text and I answered it. So here I'm back. So little c, I'm going to fill in the values that we've got. I know that side A is 11, side B is 5, minus 2 times 11 times 5 times the cosine of 20 degrees. So I'm going to do again what I just said. I'm going to take the cosine first. So type in 20, take the cosine, multiply that by A and B. So times 11 times 5, and then multiply it by 2. Now I'm going to make sure that 2 is negative. So 2 negative equals, this is negative 2 times A times B times the cosine of 20. And now I'm going to add 11 squared, and I'm going to add 5 squared. I'm pretending that I don't know what those numbers are. Now I've got everything on the right-hand side. So I can take the square root, and I get that C is approximately 6.53 units. believe I did everything to 2 decimal places here for sums. And yes, we got 6.53. Now, this is really important. When you're using the law of cosines, if you have one angle that is probably going to be larger than the others, use it first, find it first. So let's just label the sides that we have. We know that side C is 6.53, side B is 5, side A is 11. 11 is definitely the longest side. So A is the longest side. That means angle A will be the largest angle. That means that's what we want to find first. So we're looking for angle A. That means I'm going to use this form. A squared is equal to B squared plus C squared minus 2BC times the cosine of A. But I want to find the cosine of A and then therefore A. So the first thing I'm going to do is subtract B squared and C squared from both sides. So now I'm going to have A squared minus B squared minus C squared equals negative 2BC cosine A. Can I get rid of some of these negatives? Is that a hard thing? I don't have to do this step, but it makes the formula that we're getting a little nicer looking. So if I multiply the left-hand side by -1, I get negative A squared plus B squared plus C squared equals, and on the right-hand side, I have positive 2BC times the cosine of A. Again, I want to find the cosine of A. Therefore, I want cosine A by itself. So I'm going to divide both sides by 2BC. And since this A is the only negative term in the numerator, I want to put it not at the beginning. So I get that the cosine of A, I'm going to put it last just because it's good for A to be last sometimes. So I've got B squared plus C squared minus A squared divided by 2BC. And then I'll take the inverse cosine or the arc cosine of both sides. I'm starting with angle A because side A is the longest. Let's do that. We know that B is 5, A is 11, and side C, what did we say? 6.53. All right. So I have 6.53 squared plus 5 squared minus 11 squared equals. Now I'm going to divide by 2, and then I'm going to divide by B, and then I'm going to divide by C. I don't have to do that at one time. Divide by 2, and then divide by B was 5, then divide by C was 6.53. Notice that we get a negative value. And that makes sense because cosine in the second quadrant, we've got an obtuse angle A bigger than 90 degrees. So let's write that down. A is greater than 90 degrees. It's obtuse. That means that angle A is in the second quadrant. Cosine goes with X, and X is negative in the second quadrant. That's great. Okay, so now we can take the arc cosine or the inverse cosine of both sides, and we get that, let's use 1 decimal place. We get that angle A is approximately 144.8 degrees. And that's what we get. Groovy. When I wrote these notes up, I don't mind negatives in equations and formulas. but one of my students didn't like it, so I thought I would do it differently for y'all. Okay, so in fact, I want to remember to modify the notes so that it looks more like what we just did. Groovy. Well, now, what do we have? We know angle A is approximately 144.8 degrees. We know angle C is 20 degrees. We know all of the sides. Hey, can we find angle B? Yeah, we know that the total sum of the angles is 180 degrees. So the measure of angle B is going to be 180 minus the measure of angle A plus 20 degrees plus the measure of angle C. Well, we get 144.8 plus 20. C plus A is 164.8. And let's add that to 180, and we get that the measure of angle B is 15.2 degrees. By far the smallest angle and by far the smallest side. So that's cool. Now, how can we check our work? Let's use the law of sines. Why not? So let's see. Let's use sine B over side B equals, which angle did we start with? C. Let's sine C over side C. Let's see if this is correct. We got that B was 15.2. We want to find the sine of 15.2 divided by 5 and see how that compares with the sine of 20 degrees divided by 6.53. Okay. So let's see, 15.2 sine divided by 5. And on the left-hand side, I get 0.05243, etc. 0.0524. On the right, I've got 20 degrees. Take the cosine. 20 degrees, take the sine, and divide by 6.53. And I get that this is approximately 0.052376, etc. Hey, if we round even to 4 decimal places, we get it matches because the 3 is going to round up because of that 7. So it's good. We did a good job. All right. Well, what if we're given 3 sides? What if we're given that A is 8, B is 19, and C is 14? We have to use the law of cosines because the law of sines requires that we have at least one angle. And since we're using the law of cosines, it helps to start with the longest side. So I'm going to start with side B. That means I'm looking for angle B first. B squared equals A squared plus C squared minus 2AC times the cosine of angle B. So we're looking for angle B. We're given A, B, and C. So let's solve this equation for cosine of B. I'm going to subtract A squared and C squared from both sides. I get B squared minus A squared minus C squared is equal to negative 2 AC cosine B. Well, now let's divide both sides. Do you want me to do it the same way we did it before or with the negative? Okay, I'll do it the same way. So we're going to multiply both sides by negative 1, and that'll give us negative B squared plus A squared plus C squared equals positive 2AC times the cosine of B. Now we divide both sides by 2AC, and we get that the cosine of B, I'm going to write the B squared last, is A squared plus C squared minus B squared divided by 2AC. And again, A is 8, B is 19, and C is 14. Groovy. I'm going to start with A. A is 64, A is 8, so square root of 64, plus C is 14. I'm going to pretend I don't know what that is, 14 squared, minus, and then we're subtracting 19 squared. I'm going to try to pretend I don't know that. We get a negative amount in the numerator, which is good because that means that the measure that angle B is going to be greater than 90 degrees. Okay, so we get negative, and we're dividing by 2 times A times C. Divide by 2, divide by A is 8, and then divide by C, which is 14. This is the cosine of angle B. So I get that angle B is approximately 116.8 degrees. 116.8. All right, now we can use any method we want to find the next angle. We have all the sides and one angle. So yeah, let's use the law of sines. Let's see which side is next in order. Let's find angle C. So we know sine C over little c equals sine B over little b. We're looking for sine C, and we're starting with angle C because side C is next in the line. We have 19 for B, 14 for C, and 8 for A. All right, so if I multiply both sides by little c, I get that the sine of angle C is little c times the sine of angle B divided by side C. Let's find out what that is. Can angle C be obtuse also? Can you have two angles in a triangle that are greater than 90 degrees? Can you? Can you? No, that's good. Because 90 plus 90 is 180. You would have no other angle. All right, so we've got 14 times B. We just found B. That was 116.8. And we're dividing by side B, which is 19. So the sine of angle C is approximately 0.65769, etc. And let's find the inverse sine of both sides. We get that C is approximately 41.1 degrees. Let's find angle A using also the law of sines and see if when we add up the three angles, we get the right answer. We get 180. So let's find, we know the sine of angle A divided by little a equals the sine, let's use B and B again. I'm looking for angle A, so I'm going to multiply both sides by little a. And I get that the sine of angle A is little a times the sine of B divided by little b. Little a is 8. B was 116.8 sine, and we're dividing by little b, which was 19. So I get that the sine of A is 0.3758, etc. I want to find the inverse sine, and I get that angle A is approximately 22.1 degrees. I'm rounding up to 1 because I have 0, 7, 7 is greater than 5. So we have the three angles. The measure of angle A was 22.1. The measure of angle B was 116.8, and the measure of angle C was 41.1. Let's see what we get when we add those. 22.1 plus 116.8 plus 41.1. Yay! We could always be a little bit off, and that's all right, but it's nice to have an exact answer. Great. What if we have, oh, I see, this time they're not telling us what we're given. Groovy. We're given angle A, side B, and side C. Gosh, what could this be? Let's just draw. There's a triangle. I'm going to call this angle A. That means the side opposite has to be little a. And I want side B to be at the bottom. Well, that means the side opposite, the angle opposite has to be angle B. Well, there's only one angle left. That must be C. So the side opposite is little c. And what did they give us? Angle A, side B, and side C. So we have side, angle, side. The reason I went through that is so that you could see no matter how you draw the triangle, no matter how you label the sides, as long as the sides are opposite the corresponding angles, you will always get side, angle, side if you're given this information, a little b, little c. Okay, so what should we find first? You know, I think we could use the law of cosines to find side A, where we have angle A, we have sides B and C. Let's do that. We know that little a squared is equal to b squared plus c squared minus 2bc times the cosine of A. You don't have to memorize that, but please put it someplace where you can have it, that you remember. We're going to take the square root of both sides so that we get A. All right. Let's see. So B is 5, C is 8, and A is 29 degrees. We have 29 cosine times 8 times 5 times -2. And now I'm going to add 25 and 64. And I'm going to take the square root of both sides. And I get that side A is approximately 4.36. Okay, super. So now let's see what we've got. A is 4.36, C was 8, and B was 5. So the longest side by far is side C. Let's find angle C next. Let's go ahead and use the law of cosines for fun, because it's always nice to practice. That means I'm going to start with little c squared equals a squared plus b squared minus 2ab times the cosine of angle C. And we're looking for angle C. So I'm going to subtract a squared and b squared from both sides. I get c squared minus a squared minus b squared equals negative 2ab cosine of c. Let's divide both sides by negative 2ab. And we get that the cosine of angle C, I'm going to go ahead and play negative this time, is c squared minus a squared minus b squared divided by negative 2ab. Oh, the reason why I wanted to do angle C was that since side C is the longest side, the only angle that could possibly be obtuse, greater than 90, is angle C. So I want to see, is it greater than 90? And the law of sines would not tell us that information. So let's see. We've got C is 8, so we've got 64 minus 4.36 squared, 4.36, 4.36 squared minus B was, okay, so 25 equals, and we're dividing both sides by negative 2ab, so divide by 2, negative, divide by A was 4.36, and we're dividing by 5 also. So the cosine of angle C is approximately negative 0.45849, etc. I don't know what I just did. Let's see if I can undo what I just did. I'm just going to do this again. So I had c squared. C was, okay, it was 64 minus 4.36 squared minus b was 25. B squared is 25 equals. Now we're dividing both sides by negative 2 and then dividing by 5 and then dividing by a, which is 4.36. And I get a negative value for the cosine, then inverse cosine. Oh, my radians. Oh, my goodness. Okay, let's take the cosine of that. Now I know. All right. I was so confused. Okay, so now we're going to take the inverse cosine in degree mode, and we get, yay, that it is obtuse, that C is approximately 117.3 degrees. Let's find angle B. I think it's the only one left. Is that right? What did we find already? We found side A. We started with angle A. Okay, that's right. So we knew that angle A was 29 degrees, and we just found that angle C is 117.3 degrees. Let's find angle B using the law of sines and check by adding up the angles and seeing that we get 180 degrees. So I know that the sine of B divided by little b equals, I'm going to start with the angle we were given, A. The sine of A over little a. It doesn't matter which one we use, but it's always nice to use something that was given in the beginning. So the sine of B, that's what we're looking for. Little b is 5. A is 29. Little a is 4.36. I'm going to multiply both sides by 5 before I put anything in my calculator so that I have the sine of B by itself. Sine of B is 5 times the sine of 29 degrees divided by 4.36. And let's see what that is. Sine of 29 times 5 divided by 4.36. And I get that the sine of Angle B is 0.5559 and inverse sine is 33.8. So B is approximately 33.8 degrees. And what do we get when we add them? We've got 33.8 plus 29 plus, and then 117.3. Yay, that's not bad. Excellent. I got the same amount. Isn't that funny? Groovy. All right. Welcome. Okay, again, let's pretend we don't know whether we need to use the law of sines or the law of cosines, and we don't know what combination of things we've been given. So I'm going to draw a triangle. I've been given angle B, so I'm going to put that down. Side B is opposite angle B, and that's 9. I could put angle A at the top or at the bottom, and it doesn't matter. Let's put angle A at the bottom. That means angle C is up top. That means little a, side A, is opposite angle A, and little c is opposite angle C. Now let's see what we were given. We were given angle B, side A, and side B. That's angle, side, side, or side, side, angle. And let's see, side, side, angle. Side, side, angle, that's arbitrary, or what did I call it the other day? The ambiguous case. And that's what we had. All right. So I remember that if I'm given the ambiguous case, I have to find H. H is going to be the sine of B times the other angle, times the other side. So times 10. And I want to see how that compares with side B. And I can already see that side B is less than side A. B is 9, A is 10. So there's a possibility of two triangles if H is smaller than B. 10 times the sine of B, B is 82, is 9.9. 9.9 is greater than B. H is greater than B. How many triangles are there if H is greater than B? No triangles. Cool. Let's see. Yeah, we got the same thing here. So H is 8 times the sine of B, which is approximately 9.9. And since side B, the opposite side, is smaller, there's no triangle. And if you went ahead and used the law of sines, forgetting to find H, you would get an error. You would get that the sine of A is greater than 1. And when you did the inverse of this amount to find A, it would get an error. Again, let's pretend we don't know. And it says, use any combination of the law of sines and the law of cosines to solve the triangle given. Well, this time I want to put A in the bottom. A is 34 degrees. And I do have little a. That's 11. C. I'm going to put C at the bottom. So angle C is opposite. That means that side B has to be the only unlabeled side, and angle B the only unlabeled angle. I've been given an angle and two sides, and the angle isn't between the sides. That means I have side, angle. Again, that's called the ambiguous case. And I need to find H. And this time, H is going to be, we always start with the angle. We take the sine of that angle, and we use the side not opposite. So I'm going to multiply by C. And let's see what that is. A is 34. Sine times, and C is 18. I get that H is equal to, let's just call it 10.1. How does H compare with A? Oh, H is less than A because A is 11. Is A less than C? It is, yes. This is the only time when there are two triangles. So we're going to have the triangle when B, is it B that is going to change? Yes. So we're going to have the triangle where angle B is obtuse and the triangle where angle B is acute. All right. So the first thing we do is just use the law of sines. We've got side C, side A, and angle A. Oh, it's angle C that's going to change, right? Because we've been given that side. Right. So I've got the sine of C divided by little c equals the sine of A divided by little a. I put the angles in the numerator because that's what we're looking for. And since I'm looking for the angle C, I want to go ahead and get rid of everything else on that side. I have the sine of angle C is equal to little c times the sine of angle A divided by little a. Angle A was 34. Side C was 18. And I think I did not press, okay, sine times 18 divided by little a is 11. So the sine of angle C is 0.915, etc. And that means that angle C is 66.2 degrees, the acute version. That means that the obtuse version is going to be 180 minus the acute one. And if we subtract 66.2 from 180, we get 113.8 degrees. So we've got two cases. We've got the case where angle C is acute and is 66.2 degrees. And we have the case where angle C is obtuse and it has measured 113.8 degrees. So we're going to set this up where we're solving two triangles. One of the triangles is going to be all of the subscripts are little a's, so I remember I'm using C sub A. And the other triangle is going to be all of the subscripts are going to be O's because I'm using C sub O. All right, so we can use the law of sines to find the missing side. We're using just the sum of the angles to find the missing angle. But let's go ahead and check. Let's use the law of cosines just for fun to find the measure of angle B. So I've got B squared is equal to A squared plus C squared minus 2AC times the cosine of B, and that's what we're looking for. So I've got B squared minus A squared minus C squared divided by negative 2AC is equal to the cosine of B. Let's see what that is. B was 19.36. Squared minus A was 11 minus C was 18. I, for some reason, can't remember 18 squared. And we're dividing both sides by negative 2 and by A and by C. And I get that the cosine of angle B is 0.17724, etc. Or that angle C has measure 79.79. I'm going to call it 79.8 degrees. And let's see, hey, that's the same thing. We got the same thing. So isn't that lovely? Now we have to do all of that again with C sub O, with the obtuse form of angle C. We get that the measure of angle B sub O is 36.2 degrees, and that the little side B is 11.62. Do some applications, and then we're going to do a proof. All right. A 47-foot long, oh, there we go, a 47-foot long boom. And the boom, I think, is this, is what they call the grid-looking thing, is attached to a crane platform, which is this. That's the platform at point D. A cable is attached to the end of the boom at point B. The 13-foot A-frame, oh, I see, that's what they're calling. They're calling this lower side 13 feet, and the angle there is going to be 8. So we've got this triangle. We've got 13 feet, angle A, angle D. That means the side opposite is going to be little d. The side opposite A will be little a. The missing angle here is going to be B, because this is labeled B. So 13 is going to be little b, and we know little a is 47 feet. It's anchored by a counterweight. Okay, that's the counterweight. If angle BDA, okay, this angle is 80 degrees. Find the length of the cable, AB. So find the little d to the nearest foot. Well, this time I'm given side, angle, side, and that means law of cosines. So I'm starting with D, that's what we're looking for. D squared is equal to A squared plus B squared minus 2AB times the cosine of D. We're going to take the square root of both sides to find D. Let's see what we get. A was 47, so 47 squared plus, what was B? 13. Plus 13 squared equals minus 2 times A was 47. Oh, okay. I'm going to start with the other way because I messed up and I'm going to continue to mess up, I think. Okay, D is 80 degrees. Let's take the cosine first. And then multiply that by AB times negative 2, where A is 47 B is 13. And we're also multiplying by -2. We get -212.198, whatever, etc. This is -2ab times cosine d. And now we're going to add 47 squared plus 13 squared. And I get that little d squared is 1265.81, etc. You take the square root, and I get that d to 2 decimal places, let's say. Oh, it says to the nearest foot. So we're going to round to the nearest foot. That means 47 feet. Hey, that's interesting. This is almost an isosceles triangle. One of the legs is exactly 47. The other leg was shorter than 47, but we rounded up. And remember, an isosceles triangle is a triangle where 2 of the sides have the same length. That also means that the angles at those bases are the same. Okay, a public park is surrounded by sidewalks of lengths 89 feet, 122.5 feet, and 120 feet. What is the corresponding angles for the green? Oh, okay. So we've got 3 sides and we want to find the angles. And they do label. Angle A is lower left, angle B, lower right, angle C is up top. I'm always going to start, since I've got the 3 sides, I have to use law of cosines. And always we start with the longest side. So that means I want to find the cosine of A, and that little a is 122.5 feet. Little b will be 89 feet, and little c 120 feet. So I've got a squared equals b squared plus c squared minus 2bc times the cosine of angle A. I'm trying to find angle A, so I want to put everything else on the other side. A squared minus b squared minus c squared divided by -2bc equals the cosine of A. Let's see what we get. We have 122.5 squared minus b was 89 minus c was 120. Okay, now we've got this number, -7314.75 is a squared minus b squared minus c squared. Now I'm going to divide first by -2, then by b, 89, and then by c, 120. And this is the cosine of angle A. So the cosine of angle A is approximately 0.342450, etc. So the longest side is side A. That means that the largest angle will be angle A, and it's not going to be obtuse in this case because the cosine is positive. So let's find the inverse cosine, and we get that the measure of angle A is approximately, now if I round to 1 decimal place, this 9 becomes a 10. That means 69 is bumped up to 70. So 70.0 degrees for angle A. Now let's use the law of sines to find the next largest angle, and that'll be angle C. So I know that the sine of angle C divided by side C is equal to, let's use the angle we have, the side of A, the sine of A divided by side A. Let's multiply both sides by C. So we get that the sine of angle C is little c times the sine of angle A divided by little a. Okay, what do we have here? 120 is C times A was 70. We're taking the sine and we're dividing by little a. Little a was 122.5. So I get that the sine of C is 0.920515, etc. Let's take the inverse sine. We get that angle C is approximately 67.0 degrees. Well, let's find the missing angle, angle B, using the law of sines, and then check by adding the angles. I'm just doing that for fun. So we know that the sine of angle B divided by little b is equal to the sine, let's use angle A again, over little a. It doesn't matter which one we use, whether we use A or C. I want to get sine of B by itself, so I'm multiplying both sides by side B, and I get that the sine of B is little b times the sine of angle A divided by little a. Little b was 89. Angle A was 70. Take the sine, and we're going to divide by little a, which was 122.5. And I get that the sine of angle, which one is this? Angle B is 0.682715, etc. And we take the inverse sine and we get 43, and I'm going to call it 43.1, and that will be an error. When I did it on paper, when I did it in the notes, I got an exact answer. So let's see what happens if I type it in again. I have 70 sine times 89 divided by 122.5. That's 0.68, etc. Take the inverse sine of both sides, and I again get 43.056. So I do get 43.1, although it's a small 43.1. And if we add the angles, we're going to get 180.1. So let's see. We've got 70 plus 67 plus 43.1. And we get 180.1. Marvelous. Okay. A boat is sailing due east, parallel to the shore at a speed of 20 miles per hour. Okay. It's really important that it is going exactly due east. And it's going 20 miles per hour. At time t, the bearing of a lighthouse, let's call this T, the bearing of a lighthouse is south 68 degrees east. What's the lighthouse about? Here, I guess? LH, lighthouse. So that this would be 68 degrees. At time t plus 30 minutes, the bearing is south 52 degrees east. Okay, this is t plus 30 minutes. And we have south, where did it go? 52 degrees east, and we want to find the distance from the boat to the lighthouse from the boat's second position. Oh, okay, so we want to find this length. Let's call it, let's label 68 degrees angle A, so that the side we're looking for is little a. And let's see, what do we have? So we've got two angles. Gee, are they in the same triangle? Let's call this second position B, and let's call the lighthouse C. So that side B is opposite angle B. Angle B is one we do not have yet. Angle C is at the bottom, and side opposite, we don't have that either. Okay, great. We know how fast the boat is going, and we know how long. It went 30 minutes, and it's going 20 miles per hour in minutes. Oh, it went T plus 1/2 hour. So how far can a boat go in half an hour if it's going 20 miles per hour? Well, 20 miles per hour, but we're multiplying by 1/2 hours. So we're dividing by 2. It goes 10 miles. So side C is 10. And what do we have? We have miles. We have an angle, a side, and we almost have an angle. What do we know about the angle 52 degrees and the angle B? What's true about them? Excellent. We know that angle B plus 52 degrees is 180. So we can find angle B. 8, 7 minus 5 is 2. So the measure of angle B is 128 degrees. And now, finally, I see that I've been given angle, side, angle. Angle, side, angle. Angle, side, angle. Which one do we use for angle, side, angle? Remember? That's right, law of sines. So all we need to do is use the law of sines to find side A. I know that A over the sine of A equals, let's see, the things that I have side C over the sine of C. Wait, I don't have C. I don't have angle C, but I do, don't I? Okay, yes, we know that angle C is going to be 180 degrees minus A plus B. 68 degrees plus 128 degrees. Let's see, the sum of 68 and 128, 8, 9 is 196. No, that can't be right. I must have done a wrong math here. I think it is. Okay, I'm gonna just check this out. I'm back. I was being I forgot, which happens in with bearings. The angle is always with respect to the horizontal, with respect to the vertical, with respect to the north-south line. So 68, south 68 degrees east, A will be, the angle given is 68. Angle A is going to be 90 degrees minus 68. and that will be 22 degrees. They gave us that the second bearing was south 52 degrees east. This will be the lower angle. So the angle we want is going to be 90 plus 52. This whole angle is angle B. So the measure of angle B is going to be 90 plus 52 degrees. We get 114 with a 2. Okay, 142 degrees. So angle B is 142, angle A is 22. Now we can find angle C. The measure of angle C is 180 minus the measures of angle A and B. Let's see, 22 plus 142 is 164. And 180 minus 164 is 16 degrees. So now we can find side, let's see, we're given side C, we want to find side A. And I know that A divided by the sine of A equals C divided by the sine of C. I want to get little a by itself. That's what I'm looking for. So I'm going to multiply both sides by the sine of angle A. And I get that A is equal to little c times the sine of A divided by the sine of C. C was 10 miles. Angle A was 22 degrees. And angle C was 16 degrees. Let's see what we get. (22) sine times 10 divided by 16 sine equals. So I get that the missing side, side A, is 13.6 miles. Ooh, okay, that was fun. I got the same answer. Yay. All right. We're going to look at one more thing, and then we're going to look at the proof for the law of cosines. This is very important, especially in physics classes. I don't remember using it in engineering classes, but we may have done. But I know we use it in physics. Heron's formula to find the area of an oblique triangle. Remember, oblique means not a right triangle. So if S is half of the sum of the sides, the area of the triangle is the square root of S times S minus A times S minus B times S minus C, where A, B, and C are the sides. This is credited to the Greek mathematician Heron. The only way I know to do this easily is to write everything down. We know that S is equal to 1/2 of 21.3 plus 6.1 plus 22.4. And let's see what S is. 21.3 plus 6.1 plus 22.4 and multiply by 0.5. We get 24.9 for S. I need S minus A, S minus B, and S minus C. I've got S. Okay. S minus A is 3.6. F minus C, I don't know why I did them in that order, but it doesn't matter, is 5.2. It's 2.5. And S minus B. 24.9 minus 6.1, we get 18.8. And now I find the product of 29.4, 3.6, 2.5, and 18.8, and take the square root of that. So the area is equal to the square root of 24.9 times 3.6 times 2.5 times 18.8. Let's see what we get. 24.9 times 3.6 times 2.5 times 18.8. I get the square of what I'm looking for is 42,130.8, but I want the square root for A. So A is approximately 205. Let's do, it doesn't say how many decimal places, so let's do 2. So it'd be 26, and it'll be square units. So since these values didn't have units. Okay, what if you need to find the area of a triangle, but you're not given all 3 sides? You're given 2 sides and an angle. Is this the law of sines or the law of cosines? Let's see. Let's draw a picture. They gave us B and little b, and little a. Let's see. Angle, side, side. Side, side, angle. So to find, what could we find next? Let's use the law of sines to find angle A. And after we find angle A, we can find angle C, and finally we'll be able to find side C. So we've got the sine of A divided by little a is the sine of B divided by little b. I'm going to multiply both sides by little a, so that the sine of angle A is going to be little a 1.9 times the sine of 30 divided by 3.5. So the sine of A is 27.2714, etc. The arc sine of A is 15.7 degrees. Now, angle C, if we just subtract the sum of those angles from 180, it'll be 180 minus 30 minus 15.7, and I get that angle C is 134.3 degrees. So finally, now we can find side C. Let's go ahead and use the law of sines again. I know that little c divided by the sine of C is little, let's see, we started with B and B, let's use B. B divided by the sine of B. C is equal to B times the sine of C divided by the sine of B. And what do we get? Little b is 3.5 times angle B is 30. We're taking the sine divided by, oh, I did that backwards. So little b times the sine of C divided by the sine of B. Okay, little b was 3.5 times C was 134.3 sine divided by the sine of 30. And we get that the missing side is 5. Finally, we can use Heron's form. So I've got A equals 3.5, B equals 1.9, C equals 5.0. We might as well use the same decimal place. And let's find S. 3.5 plus 1.9 plus 5 equals, and then we're dividing by 2 or multiplying by 1/2. Same thing. So S is 5.2. S minus A, S minus B, and S minus C are the next things we need. Let's see, 5.2 minus 3.5 is 1.7. 5.2 minus, let's see, B was 1.9 is 3.3. And 5.2 minus 5 is 0.2. So we're finding the product of 5.2, 1.7, 3.3, and 0.2, and we're going to take the square root of that product. All right, what did we get? 5.2 times 1.7 times 5.2 times 1.7 times 3.3 times 0.2 equals, then we take the square root, and I get that the area, let's do 2 decimal places, is 2.42 square units. Okay. Finally, let's finish up with a proof of the law of cosines. So got a triangle. Angle C is in the lower left, angle B is up top, angle A is in the lower right, and I'm going to call point D the place where a perpendicular is dropped from angle B to the side CA. The cosine of angle C, gosh, I have to use that D, don't I? CD is this length, and the cosine of angle C will be CD divided by A. Oh, there it is, CD divided by A. And we're trying to replace CD with something. So if I multiply both sides of this by side A, I find that this distance, CD, is equal to little a times the cosine of angle C. All right, that's a piece. Now, I need to see how long is this missing side, AD. Well, I know that AD is equal to B is the entire side minus CD. So AD is equal to B minus A cosine C. So now I've got I've got more information about the labels on the triangle. I know that this distance between C and D is A times the cosine of C. I capitalize sine and cosine sometimes so that it's easier to tell them apart from the sides. And I see that side AD is the whole side B minus CD, which is A times the cosine of angle C. Now I do have all the sides labeled. So let's see. What is the sine of angle C? Well, the sine of angle C is H over A, so that H equals A times the sine of C. Oh, I see where we're going. I had forgotten. Sorry, guys. So H is A times the sine of C. CD is A times the cosine of C. And I've got a right triangle with the hypotenuse of A. So let's use the Pythagorean theorem to connect these. I know that A squared, the hypotenuse squared, is equal to the sum of the squares of the legs. So A squared cosine C, so A cosine C squared plus A sine C squared. All right, well, this is A squared cosine squared C plus A squared sine squared C. Oh, we've also got, right, now I see. Okay, so we've also got, if we're trying to compare C with side C, so that's the triangle we want to look at. We want to look at this triangle that has measurements H equals A sine C, base, which is little b, minus A cosine C. Everything is in terms of angle C, and then side C. That's our goal. Connecting sine C, well, angle C with side C. And we're going to use the Pythagorean theorem again. We get that C squared is equal to B minus A cosine C squared plus A sine C squared. Well, if you square a binomial, two terms, remember if you have x plus y squared, then you have x squared plus 2xy plus y squared. This time we have a minus in the middle, so we'll be subtracting 2xy. So I've got c squared equals b squared minus 2ab cosine c plus a squared cosine square c. That's all b minus a cosine c squared. And now we're adding a squared sine c squared, sine square c. Oh, check it out. I've got a squared cosine square c and a squared sine square c. So let's rewrite this as b squared minus 2ab times the cosine of c plus, I'm going to factor this a squared out. Because now I have something like nice cosine squared c plus sine squared c. And what is cosine squared c plus sine squared c? Excellent. So we know the Pythagorean identity, that makes cosine squared c plus sine squared c is 1. And now I have c squared is equal to b squared minus 2ab times the cosine of angle c plus a squared. A squared times 1 is just a squared. Oh, but let's put this in the order that we like. C squared is equal to a squared plus b squared minus 2ab times the cosine of c. Hey, 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 that was pretty fun. Pretty fun. The steps are all written out pretty neatly, I think. And I probably showed more work in the steps on paper. The key is that we were trying to connect side with an angle, the corresponding side with its angle. And to do so, we had to put every piece of information about the sides of a triangle, a right triangle, in terms of that angle that now isn't even part of the triangle anymore. So it's pretty cool. All right. Well, that's it for today. Hope you're all doing well, and I'll talk to you real soon.